Alright, so today we're going to be talking about chemical reactions and balancing. Now, first we're going to talk about the introduction to chemical reactions. Now, chemical reactions occur when substances go through chemical changes to form new substances. Now, this could include atoms, ions, compounds, or molecules of a single atom. And the bonds between the atoms are broken and created to form new molecules in chemical reactions. Now, chemical reactions always and must occur. And there are actually 4 signs that a chemical reaction has occurred that we can look at. The first sign is a formation of gas, bubbles. So you may have seen this if you so I have an image here of Alka-Seltzer tablets going into water. If you ever were sick or had a stomach ache and your mom or dad or guardian put Alka-Seltzers into water, you probably start seeing it bubble. That is a formation of gas, and that is a sign that that is a chemical reaction. Another one is if you ever put vinegar and baking soda together, and those bubbles forming, that's gas. It's a sign of a chemical reaction. Now, number 2 is a formation of precipitate. So a precipitate is a solid. As you can see in the image here, we have a clear solution and a yellow solution coming together to form this kind of cloudy copper orange color. That right there is a solid in a solution. So if we did evaporate or centrifuge to separate the solid and the liquid, you would get a solid after that. Now, 3 is a release of energy, so some sort of temperature change. This picture here is actually with sodium going into water. You might have seen this as a demo in Chem A. And what you probably saw was sparks or fire happened. Any kind of sparks, any kind of fire that's being produced is a release of energy. Energy is being released into the atmosphere, and that causes some sort of temperature change. And lastly, we just have color change. If we're putting 2 things together and the color changes, that is a sign of a chemical reaction. So we know a little bit more about chemical reactions. We can go and talk about the structure of chemical reactions. Okay, so chemical reactions have specific structures. So looking here, we have element/compound 1A plus element/compound 2A plus ... so meaning if there's any more. Then we have an arrow of an element/compound 1B plus element/compound 2B plus ... if we have any more. This is kind of a general look at what a chemical reaction is, and there are 4 different parts that it has. The first part, which is kind of more obvious to you, is these plus signs, and we call these plus signs addition signs like you would in math. That's just meaning that A and B is being added together, and then B and 1B and 2B are being together as well. Now then we have this arrow. This arrow is called a yield sign. So that means that A and B, 1A and 2A are being added together to yield 1B plus 2B. Now all of this stuff here to the left of our yield sign, we call these our reactants. And reactants is a substance or molecule that participates in a chemical reaction. So it's what's being added together to make a chemical reaction happen, our reactants. And everything to the right of our yield sign is called our products. And products are a substance that forms in a chemical reaction. So our reactants are being added together to react, which yields our products. So what happens after the chemical reaction has occurred. So let's go ahead and look at an example of a chemical reaction. Now we have CH4 plus 2O2 yields 2H2O plus CO2. Now again, anything to the left of our yield sign is our reactants. So in this case, our reactants is CH4 and 2O2. Again, anything to the right of our reaction is our products. So we have 2H2O and CO2 as our products. So with that idea, let's go ahead and do some practice problems, and we're going to write the reactants and products for the following reaction. So problem number 1, we have Mg plus 2O2 yields 2MgO. Go ahead and take a minute to figure out what are the reactants and what are the products. You can go ahead and pause the video, and then when you have it, you can go ahead and press play. All right, anything to the left is our reactants. So we have Mg and 2O2. And again, anything to the right of our products, in this case, we have 2MgO. Let's go ahead and do one more example. We have NaOH plus HCl yields NaCl plus H2O. So go ahead and take a minute to solve this one. And when you're ready, you can go ahead and press play. Again, anything to the left is our reactants. So we have NaOH and HCl as our reactants. And anything to the right is going to be our products. So we have NaCl and H2O. So now we know about the structure of chemical reaction and what chemical reactions are. We can go ahead and start balancing chemical reactions. But first, why do we need to balance chemical reactions? Well, chemical reactions must follow the law of conservation of mass. And the law of conservation of mass states that matter cannot be created or destroyed in a chemical reaction. This means that we can't magically get rid of atoms or elements in a reaction. And that also means that we can't just magically produce one out of thin air. What's happening is it's being converted from one compound to another compound in a reaction. Now, chemical reactions need to be balanced to follow the law of conservation of mass, so the number of atoms are equal in both the reactants and the products. Meaning, if we have 1 magnesium in our reactants, we have to have 1 magnesium in our products. If we have 5 chlorines in our reactants, we need to have 5 chlorines in our products. So these are the steps to balance the chemical reactions. The first step is we're going to box any polyatomic ions that are present on both the reactants and product side. You can find the polyatomic ions either on the back side of your laminated periodic table if you're in class, or it's going to be in the second page of the periodic table posted on the Google Classroom. Now, when you do look at these listed polyatomic ions, you will notice they have charges. In this case of balancing, we're going to ignore the charges of the polyatomic ions in the list. Now, number 2. We're going to split the chemical reactions in half based on where the yield sign is. So we're going to split the reaction in half. So it's split to the reactants only, then the products only. 3, we're going to list each atom that is present in both sides of the reactants and product side. And anything that was boxed, if you boxed anything, just rewrite them as is. We don't want to split up anything that's boxed. Step 4, we're going to identify the number of each atom that is present in both the reactants and product side, meaning we're going to figure out how many magnesiums is on the reactants and how many are in the products, or how many chlorines are in the reactants, or how many are in the products, and we just look at the subscripts. Remember, the subscripts after the element tells us how many they are, and again, if there's no number, we're going to assume it's 1 because chemists hate writing 1s. And 5, we're going to start balancing the number of atoms. So each atom is equal in both the reactants and product side, meaning if we have 1 magnesium in our reactants but 4 in our products, we need to get those equal in some way. And when we do balance these atoms, we're going to leave the hose. We're going to leave hydrogen and oxygen for last. Those should be the last 2 elements to be balanced. And we would to balance out these numbers, you would figure out which whole number you can multiply with to balance out those numbers. We're only looking at whole numbers and we're multiplying. And with the whole number you multiplied with to get those numbers equal, that will go in the blank on the sign manipulated. So if you're multiplying on the reactants, it'll go on the reactant side. If you're multiplying to the products, it's going to go on the product side. And it's going to go with the compound that has that atom. So if you're going to be If you're changing magnesium, you want to make sure it goes next to the compound that has magnesium. And then after that, you're going to change any number of atoms that are also present in that compound, if there is any. So if we're balancing out magnesiums, but it's MgO, that new number you put in the blank not only affects the magnesium, but it also changes the oxygen. And lastly, if all numbers are balanced and there's still blanks involved in the problem, just leave the blank blank. So with that being said, let's go ahead and do some practice problems.
Okay, so let's go ahead and do some practice problems of balancing chemical reactions. So looking at our first example, we have Mg plus O2 yields MgO. Your first step you want to do is you want to go ahead and figure out if there's any polyatomic ions present on both sides of our reaction, the reactants and the product side. And you would just look at your polyatomic ion list, either on the back of the class laminated periodic table or the second page of the periodic table posted on the classroom. You will see in problem number 1 there is no polyatomic ion, so we're going to go ahead and move on. The next step we're going to do is we're going to split the reaction in half. Once you do that, then you're going to list out each element that is present in both sides of the reactions. So looking in our reactant side, we have magnesium, which is Mg, and we also have oxygen, which is O. These two elements are also present in our product side, so let's go ahead and rewrite them. So now that we did that, now we got to figure out how many of these elements we have on either side. So looking at our reactant side, we only have one magnesium because we know that because there's no subscript. So that's 1 because chemists hate writing ones. Oxygen has 2 because it has a subscript of 2. On our product side, both magnesium and oxygen do not have subscripts, so we know it's going to be 1. So magnesium we have 1, and oxygen we have 1. So now that we know how many of each element we have, we want to get the numbers equal. So magnesiums are both 1, so that's equal, but oxygen is not equal. We have 2, and then we have 1. So, we're going to go ahead and to make them equal, we have to find a number to multiply by. So we're going to go ahead and take 1, and we're going to multiply that by 2 to get 2, because we want to get that to become 2 from the reactant side. The number that we multiplied by, this number here, has to go into the blank on the side we manipulated. We manipulated the product side, so it has to stay on the product side, and it's going to go here. So this 2 not only goes with the oxygen that we just looked at, but it also applies, to the magnesium. So 2 times 1 is 2. So now we have 2 magnesiums. And that causes the magnesiums to be not balanced anymore. So we have to balance them. So we can just do 1 times 2. Which equals 2. And this number that we multiplied by has to go into a blank on the reactant side with magnesium. We have this option, we have this option, and this option, but the one with magnesium is our first blank. There is no other element in this compound, and now we don't need to change anything else, and that is balanced. So we would keep this blank here completely blank. You don't need to put a number in. So with that idea, let's go ahead and move on to our next example. We have FeS plus HCl yields H2S plus FeCl2. First thing we got to do is look at our polyatomic ion list and see if there's any polyatomic ions present in both sides of our reaction. In this problem, there is none, so we're going to go ahead and just split our reaction in half. Now that we split our reaction in half, we got to go ahead and write out how many of each we have, how many of each element we have on each side. So we have Fe, we have S, Cl, and H. The reason why I listed H last is because we're going to balance the hydrogens and oxygens out last. So it's always best to just list them at the very bottom. All 4 of these are also in our product side, so let's go ahead and rewrite them. So now that we know the number of elements, we can go ahead and write out how many of each we have. So Fe, S, H, and Cl on our reactant side all have no subscripts, so we all have 1. On our product side, we see that Fe and S do not have subscripts, so it's 1. But both Cl and hydrogen, chlorine and hydrogen, both have 2. So now we know those numbers. We can go ahead and balance out those numbers. Fe is both 1 to 1, so that's good. S is 1 to 1, that's good. But chlorine's is 1 to 2. We need to get that equal, and we got to do some sort of multiplication. And the only thing that we can do is do 1 times 2, which will equal that 2. And this number that we multiplied has to go in our reactant side, and it has to go on the side into the blank with chlorine, and the only one is this one. And we just said this applies to chlorine, but we also have hydrogen in this compound, so it also changes hydrogen. So 2 times 1 is 2, and that causes the hydrogen to be balanced. And this is your final answer, and again, we're going to leave this blank, and this blank completely blank. Okay, so let's go ahead and move on to our next example. This time we have MgNO3 plus Ki yields KNO3 plus PbI2. So for this one, we got to first figure out if there's any polyatomic ions present. And in this problem, we do have a polyatomic ion. And the polyatomic ion that we have is nitrate, and nitrate is NO3. So we're going to go ahead and box NO3. That is the only polyatomic ion that we have. So let's go ahead and split our reaction. And we're going to list out all the elements we have on both sides of our reaction. The first element we have is Pb. And you see how we boxed NO3? We want to rewrite NO3. Anything that is boxed, you're just going to rewrite when you list out your elements. Okay? And then next we have potassium, which is K, and then iodine, which is I. All 4 of these are also in our product, so let's go ahead and rewrite them. And now we have all those numbers. We can go ahead and list out how many we have. So looking at our reactants, we see that Pb, K, and I do not have subscripts, so it's just going to be 1 for all 3 of them. If you see the number outside of the box, we have a 2. That means we have 2 NO3s. Looking at our reactant side, K, NO3, and Pb do not have any subscripts, so we have 1 K, 1 NO3, and 1 Pb. And particularly with NO3, we always look at the number outside of the box. Since there is no number outside of the box, that's why it's 1. And iodine I has a 2. So now that we have those numbers, we can go ahead and balance them out. Pb is both 1 to 1, so that's good. NO3 is not equal, so we have to find a number to multiply by to make it equal. And the only thing we can do is do 1 times 2. And this 2 that we multiplied with has to go on our product side since we're changing our products with NO3. The only blank that's in our product with NO3 is the first one in our products. So we already know that this one applies to our NO3, but we also have K. We also have potassium in this compound. So we have to take 2 times 1. That means potassium has 2. So we got to continue on since we're not done balancing yet. So moving on to our potassiums, they're no longer balanced. We got 1 to 2. So we got to figure out a number to multiply by to make this balance. So we're going to take 1 times 2 on our reactant side. And this number 2 has to go into the blank on our reactant side this time, since we're changing our reactants with the blank that has potassium. So it has to go right here. And we already know this applies to our potassium, but we also have iodine in this compound. So we have to take 2 times 1, and that becomes a 2. And that causes the iodine to be balanced as well. And that is your final answer for example number 3. So let's go ahead and move on to example number 4. We have C7H16 plus O2 yields CO2 plus H2O. First step we got to do is figure out if there's any polyatomic ions present. This problem, we don't have any polyatomic ions present on both sides, so let's just go ahead and split our reaction. And we got to list out each element that's present on both sides. We have C, H, and O. They are also present in our product side. So now let's go ahead and find the total of each. Carbon, we have 7. Hydrogen, we have 16. Oxygen, we have 2. Now carbon on our product side, there's no subscript, so it's 1. Hydrogen has a subscript of 2. Now we do have an issue with carbon. As you can see, carbon is both present in the oxygen. We have an issue with oxygen. Oxygen is present in CO2 and H2O. So we got to take the sum amongst all of those elements. So let's go ahead and looking at carbon, we have 2 oxygens. H2O, there is no subscript, so we have 1 oxygen. So 2 plus 1 equals 3. Okay. So now let's go ahead and balance out these numbers. Carbon is definitely not balanced, so we have to find a number to multiply to make it balanced, and we could just do 1 times 7. So this 7 here has to go in the blank in our product side since we're changing carbon, with the blank that has carbon, which is this one. We know this applies to the carbon, but it also applies to the oxygen. So we take 7 times 2, which makes 14, not two oxygens anymore, oxygens anymore. And we still got to take 14 plus our 1 from our H2O. So we have 15 oxygens now. Moving on to hydrogen, so we got to find a number to multiply, which we can do 8. And this 8 has to go on our product side with hydrogen. And we know this applies to our hydrogen, but it also applies to our oxygen again. So 8 times 1 is 8, but we got to do 14 plus 8. And that equals 22. And finally, we can balance our oxygens out by doing 2 times 11 to equal 22. And that 11 that we multiplied by has to go in our reactant side with oxygen. And there's no other element in O2 besides oxygen, so this is all balanced. I know this one's a little bit complicated, but it's very helpful if you take into account the number of oxygens you have above those elements, so you know the total. It'll make things a lot easier. Okay, so let's go ahead and move on to our next example. This time we have Cu plus AgNO3 yields CaNO32 plus Ag. First thing we got to do is figure out if there's any polyatomic ions present on both sides. In this problem, we do have a polyatomic ion, and it is nitrate, NO3. So let's go ahead and box NO3. Okay. Now we got to go ahead and split up our reaction and list out how many of each, all the elements we have on each side. So we have Cu, Ag, and then NO3. And this is also present in our product side. Cu, Ag, NO3. So now we got to write out how many of each we have on our reaction. Cu, there is no subscript, so it's going to be 1. Ag has no subscript, 1. And NO3, the box, there's no number outside of the box, so it's going to be 1 as well. Looking at our product side, Cu still has no subscript, so it's 1. Ag has no subscript, so it's 1. And NO3 actually has a number outside of the box, so it's going to be 2. So let's go ahead and balance. Our Cus are balanced, our Ags balanced, but our NO3s are not balanced. So we got to go ahead and multiply by 2. And this 2 has to go in the side that has,
Nikia Sago, please go to the main office. Nikia Sago, please go to the main office.
it has to go into the side with the reactants because that's what we're changing. It has to go in the blank with NO3. And the only option we have is here. Now, we did say we're changing our NO3s, but this 2 also applies to our Ag. So 2 times 1 is 2. So that means our silvers, our Ags, are no longer balanced, so we have to balance them by going on our product side, multiplying by 2, and this number 2 has to go in a blank in our product side with Ag, and it'll go here. There's no other element over here on this side besides Ag, so this is your final answer. And finally, let's go ahead and do our last problem. And we have N2 plus H2 yields NH3. There is no polyatomic ions in this one, so we're not going to box anything, but we're going to split and we're going to list. There are 2 nitrogens because we get that from our subscript number, 2 hydrogens because we get that there, 1 nitrogen because there's no subscript, and we have 3 hydrogens because it's 3. Now, I know I said never start with hydrogen, but for this problem, I want to start with hydrogen because I want you to see what happens if we have, like here, 2 and 3. There's really no number we can multiply to make it a 3 or make it a 2. When you have this issue, you want to do the greatest common factor, and the greatest common factor between 2 and 3 is 6. So we have to make both numbers equal 6. So this 2 here has to go on our product side, and this 3 here has to go on our reactant side with hydrogen. Now for H2 on our reactant side, there's no other element, but in our product side, we have not only hydrogen that we know of, but we also have nitrogen. And 2 times 1 makes that 2, and that makes that balanced. Now that we know what reactions are, what they look like, and balancing them, we can go ahead and finish off with talking about mole ratio. Now, mole ratio, so in a balanced chemical reaction, compounds react in set ratios called mole ratio. And a mole ratio is the ratio between the atoms in moles of 2 compounds involved in a chemical reaction. So essentially, it's based on the coefficients in a balanced chemical reaction. So with this idea, let's go ahead and just do some practice problems where we're going to use the balanced chemical reaction below and find the mole ratio for the following requests. So we're going to be looking at this reaction. We have 4Al2O3 plus 9Fe yields 3Fe3O4 plus 8Al. The 4, the 9, the 3, and the 8 are the coefficients that, if we balanced it, those would have been produced to balance out those atoms. So let's go ahead and find the mole ratio of Al2O3 to Al. So we have Al2O3 right here in the reaction and Al. Mole ratio is based on coefficients. Well, Al2O3 has a coefficient of 4, and Al has a coefficient of 8, so the mole ratio is 4:8. That means there's 4 Al2O3s for every 8 aluminones, Als. Okay. Might want to, your first instinct is simplifying 4:8. Don't. Keep it the way it is. We don't simplify mole ratios. So let's go into the mole ratio for Al2O3 and Fe. And again, it's coefficients. Al2O3 has a coefficient of 4. Fe has a coefficient of 9, so we have 9:4.
4:9. Now for Fe and Fe3O4, Fe has a coefficient of 9. Fe3O4 has a coefficient of 3. So the ratio is 9:3. And lastly, we have Al and Fe3O4. Al has a coefficient of 8. Fe3O4 has a coefficient of 3. So it's going to be 8:3. And that is how you do your mole ratio. And that is it about chemical reactions. Thanks, guys.